Just like in trigonometry, when you prove an identity in the hyperbolic functions, you still want to show, you want to start with one side, manipulate that, and eventually show that it's equal to the other side. Or another thing you can do is you can work on both sides, right? And then meet in the middle, right? So here, we want to show cosh 2x equals cosh squared x plus sinh. Oh, that's the thing I forgot to tell you. Sine hyperbolic, usually it's pronounced sinh. And cosine hyperbolic is cosh. And then tangent hyperbolic is tanh. And there's no special names for the other ones, like the reciprocal functions, right? Yeah, that would be. All right. Anyway, so what is my left-hand side? My left-hand side, cosh of 2x. What does that mean? Well, I know that cosh x is just e to the x plus e to the negative x over 2. So if I do cosh 2x, I just replace the x's here with 2x. So cosh 2x is really just e to the 2x minus e to the negative 2x over 2. Now at this point in this proof, if this is going to be a proof, it's not quite clear at this point how I'm going to make this look like this, right? The right-hand side. So this is when you would start with now the right-hand side and see if you can somehow meet somewhere, right? Yes. Plus, I'm sorry, yes, it is plus. It's right there in front of me too. Thank you. So the right-hand side, well, what is that? So that's cosh squared x plus sinh squared x. Okay, so that, now what I can do is I can substitute in my exponential definition, right? Because that's actually what I'm trying to match it with over here, this exponential definition, right? So replace cosh with e to the x plus e to the negative x over 2 squared plus e to the x minus e to the negative x over 2 squared. All right, so now you're going to multiply all this stuff out. So e to the x plus e to the negative x squared, remember from before with that other one I showed you, the formula I just erased, we're going to square the first term, so that's going to be e to the 2x plus 2 times the product of e to the x times e to the negative x. E to the 0, that's fine, I'll write that. And then plus e to the negative x squared, that's just going to be e to the negative 2x, correct? All right. And that's all over 4. Plus, the other one's going to be e to the x squared, so that's e to the 2x, minus 2 times the product of these two, that's going to be e to the 0, plus e to the negative x squared, so that's going to be e to the negative 2x all over 4. Now, they have the same denominator, right? So we can, here I'll zoom into that. So we can cancel or we can combine like terms in the numerators. So notice that the 2e to the 0 and negative 2e to the 0, those are going to cancel. And that's it. But then we get e to the 2x plus e to the 2x, that's 2 e to the 2x. And same thing with the e to the negative 2x, we have 2 of those. And that's all over 4. We can reduce that. And what's our conclusion? That the left-hand side, right, which is this, is the same thing as the right-hand side, which is that. And that's it. That's the proof.